All right, folks, let's take a look at how to create a circuit in CircuitLab. Um, it's a pretty handy little tool for putting together and simulating circuits. If you were playing around with PartSim, it's very similar. Over on the left-hand side of the screen, we've got all the different elements we can put in a circuit, and we're just going to drag and drop them over here. So to create the AC circuit that we're looking at in our assignment, I'm going to start with this voltage function. I'm going to drag that over here. I'm not going to worry about setting any parameters at the moment. I'm going to go ahead and connect the ground. That's this little upside down triangle symbol. And just clicking and dragging the endpoints together will connect those elements together. Now, the example circuit that we're looking at has a resistor. And it also has an LED. You'll see under diodes, there's regular diodes and a light emitting diode. I'm going to select that one. And remember, that is going to be the load for our circuit. So I'm just going to click and drag the ends of the lines together to connect this circuit. And I'm going to add one more ground to this diode. And so now we got a simple diode circuit, very similar to the ones you've built with Arduino numerous times. Now I can edit elements of the circuit. For example, V1 here is a sine AC signal. If I double click that, that's going to open up a menu and let me change some options. So I'm going to play around with this. I'm going to change this to a square wave. I'm going to change the amplitude to 120. I'm going to leave the DC offset at 0. I'm going to make the frequency 60, so 60 hertz. And this would be similar to, the amplitude frequency of electricity coming out of your wall outlet. Click over to the side. Now, we're going to have a problem, as you will see in a second. If I actually built this circuit in real life, like plugging an LED through a very small 100 ohm resistor, it's probably going to burn out my LED. And so what we're going to do as part of our circuit design is try to figure out what resistance I need here to make sure the maximum voltage from my AC source doesn't exceed a parameter for this load. But before we simulate it, we're going to go ahead and name some of these nodes, these nets. I'm going to start with this one here. This is going to be my input. So this is where the power source, the voltage source in this case, is supplying power to my circuit. I'm going to add a node here, and this is going to be my load. So remember, a load is just kind of a generic term for the part of a circuit that does something, consumes power, like an LED turns on a light, a motor turns a wheel. A load is the part of the circuit that does something, and we're trying to design what goes in between the input and the load so that we can meet certain voltage and current characteristics. What we're trying to do is shape a waveform. So let's take a look at what this actually looks like right now. It's pretty easy to simulate it. If you go up to Run, we're going to do what's called a time domain simulation. So our input will oscillate. It'll go up and down as a function of time. We want to see how the circuit reacts. So a 60 hertz signal will go up and down 60 times every second. It's got a 60 hertz frequency, or once per second, period. So I'm going to set my timer, my stop time, to be, let's say, 10. So it's going to be 60 times per second. If we want to see 6 cycles, let's set that to 0.1 seconds. I'm going to make my time step, so that's the time that the computer's going through and calculating its values. Let's make that relatively small. I want to make that 0.001. And I'm going to, under Outputs, add expression. I want to see what's happening at my input. And do that again. I want to see what's happening at my load. So let's run a time domain simulation. And so we can see this circuit. The blue-green is my input. The orange is my output. And we can see how that simple resistor is changing the input signal to an output signal. So this is a square wave, so it's pretty square on the top and bottom. And of course, we can see what my peak voltages are turning into as we simulate this circuit over time. So your task is to build the circuit. You can do this one of two ways. You can either experimentally try to get this maximum minimum voltage to values of something between, I think, 1.8 and 2.4 volts is an optimal operating range for an LED. Or you can go through the calculations and figure out what that resistance needs to be. But this graph right here is a real easy way of checking and seeing what's actually happening in the circuit.